Hey guys, Y13A here. Today I want to show you guys the new X-47B that I've been working on. For the full build video, please check out my live streams that I've been doing for the past couple months. But in this video, I just want to give you guys a brief summary of the design. So this is based off of a real-life design, the X-47B, which was a UCAV, so it's an unmanned combat aerial vehicle designed for the US Navy. You know, in the real life design, there are no vertical stabilizers, which are these things here if you're new to airplanes. But in this design, I added them because the intention for this aircraft is to actually fly it outside and really test it out there. So you might notice that the top intake is also missing. So this is really just a flight optimized model. It's really not meant to be like a scale model, but it's somewhere in between where it kind of looks like the real thing, but also is a little bit different. So the overall design is a flying wing, which makes it really great for outdoors flights. From initial indoors flight testing, it flies really, really well. And I mean, like, this thing, you can just see it cut through the air, right? It's if we look at it from the side here, it's really just a very aerodynamic looking shape. So, you know, this is really a blended wing and body design, so there's really no fuselage, but I can walk you through kind of how I constructed this anyways. It started with the fuselage base, right? This rhombus, or it's not a rectangle, it's a diamond shape. We started with that and really just built a loft for the structure. You might notice from the front here that there's thickness to this design, which is intentional. We want to give it that airfoil shape so that the whole body serves as kind of a wing and provides lift in flight. So you'll notice that the leading edge here of the fuselage portion of this aircraft is very airfoil-like, very rounded. It just kind of allows the air to flow over it very nicely. So this is based on some new materials involved too. Inside the fuselage, we incorporated some popsicle sticks to increase structural strength, because this thing is going to crash at pretty high speeds. It flies really, really fast, so we want to make sure that it doesn't destroy itself in a couple of flights, and that's why I included some popsicle stick, wooden material inside. And then it's really just pretty simple that way. It's just made of straw and cardstock and popsicle stick, all just integrated very tightly in a nice lean package. Moving on to the wings, it's kind of the same story here, except I didn't use straw in this case. The only thing I used to really make the wings perform the way they do, I guess the key material here was, again, popsicle sticks. So you can get like a pack of them for about like $7 or $8, and they come in like a box of like 1,000. So it's definitely a very economical material if you want to use it. It's very high strength as well. So if you notice, I'm holding the wing by the tip, and the whole aircraft can support itself based on that one point of support. So it's very, very strong, and I can't wait to test it out. So it's also very nice because it creates a very thin wing structure as well. Previously, in all of my X-47B prototypes, I've used straw supports, which create a pretty thick cross section, and I have a feeling that sometimes because it's so thick, the airflow actually kind of separates a little bit, and it's not 100% efficient, or as efficient as it could be. So I think with this new thinner wing structure, it's definitely going to be more efficient too, because it lowers drag and simultaneously also increases the strength. So it's a win-win essentially. You're also trading off weight, right? So you're increasing weight a little bit by using these materials, but I think it's worth it because, you know, in the end, when you think about the physics of a glider flying through the air, you really want it to have a lot of momentum, right? And momentum is proportional to mass and acceleration, right? Or not mass and acceleration, mass and velocity. There we go. And your velocity can actually change as drag slows you down. But if you have a lot of your momentum concentrated in the actual mass of the aircraft, then you're actually able to keep your momentum, so to speak. And so, you know, it's true, right? You want to have some mass, but you also don't want to have too much mass. And that's where there's an equation online that describes something called the ballistic coefficient, which is really a measure of how well something travels through the air. And you can definitely do research on that. It's, you know, there's a lot of aerodynamic and I guess, you know, aerodynamic terms in that equation, but the main takeaway is that increasing the mass a little bit is worth it for this trade-off. And, you know, I really just want to test this outside. It's really sleek and dense aircraft. It's pretty heavy. Yeah, I'm really excited to test it out outside. So in the back here, we also have vertical stabilizers, right? These were kind of just made up, right? On the real aircraft, this doesn't exist, but in order to make it fly in glider form, we need a vertical surface because we don't have, you know, we don't have wing twist, which does increase stability, but that's just not very reliable. So I decided to do the vertical stabilizers here. And they're mounted at kind of the junction between the fuselage and main wing, right? So it's a very clean implementation, I think. And, you know, it works because the center of lift for this aircraft is way in the front here because there's just so much surface area. And so by placing them here, you're placing it after the center of lift, which makes it yaw stable. So these are pretty small looking compared to the rest of the aircraft, but that's kind of the point, is to minimize the amount of change that we make to this airplane, and try and keep it close to the original. On the bottom here, you might notice a structure like this, kind of looks like a fin. So this is actually the handle for the aircraft. This is where I'm going to be holding it to launch it. And so that's kind of what it serves as a function for. So not much story going on there. It does kind of act like a vertical stabilizer in a way, right? Because it's kind of behind the center of lift, but it's not really that effective, I would imagine. So, you know, it is what it is. It's mostly meant to be a handle. So that's pretty much it for this design. I kind of want to do an outdoors test of this, more so than the Rapid Prototype 004. But, you know, we'll have to wait and see when I do that. I'm testing out some new camera equipment, so you might notice that this video has a lot more blur or, you know, bokeh in the background. This is shot on a full frame camera, so I'm just testing out new things for the production side as well. So yeah, that's pretty much it for this design. Please stay tuned for the, I guess, official flight test video. But yeah, I just wanted to give you guys a brief rundown of this new X-47B model that I made. Again, if you want to see the full build, please check out the live stream sessions that I had in the past couple months. I forgot the exact dates, but it's definitely there if you want to see it. You know, the full build process. And so that's pretty much it for this video. Thanks for watching, and until next time, it's Y13A.